In this section, we will implement a web application using the functional reactive programming library RxJS. First, we will figure out what functional reactive programming is, then we will cover the fundamentals of RxJS so that we can start implementing a web application. We will use the Slack API for the implementation. Beyond the simple retrieval of API endpoints, we will also use WebSockets to establish a continuous connection that gives us live Slack message updates. So let's start with discovering the principles of reactive programming. In this video, you will learn what reactive programming is. We will then discover what event streams is all about, and we'll find out more about event streams via some examples. You will learn how to observe and capture events, how to combine event streams, and we will also talk about the advantages of reactive programming. Reactive programming is event-based and operates with asynchronous streams. Values, errors, and completion messages may appear on these streams. In a reactive program, we get a chance to observe these streams and decide on how to react to an appearing value, completion message, or error by executing callbacks. In order to discover what reactive programming is all about, we have to understand how streams work. Reactive programming also comes with some operators that look like functional programming utilities, but instead of transforming arrays, we transform event streams. Operations like map, flat map, reduce, filter are all available to us. The full list of operations is very long though, so at this stage all you need to understand is that operators may transform the values emitted by observables. An operator doesn't have to be unary. We can combine multiple observables to provide synchronization between them. An event stream is a time-based sequence of events. In reactive programming, an event may encapsulate a value, a completion signal, or an error. An event stream can be observed via the observable interface. This is an important concept. For now, just note that we wrap our events in an object called observable. Let's see some examples for event and data streams. The most straightforward example is a stream of DOM events such as clicks, mouse overs, keyboard events, mouse move, and so on. These events are continuously monitored and can be handled in real time. HTTP requests are also often used as potential event sources. In case we leave the connection open, streaming APIs can continuously update us with new event objects in the form of a JSON string appended to the already open connection. The term lists and sequences may be a bit too vague at first sight. We can turn any sequence into a data stream. Last but not least, in Node.js we can access the file system and we can read and write contents of our files line by line. Imagine these operations like the lazy.js example in section 1. Observers listen for events appearing in the stream. These events may be captured, and asynchronous callbacks may be linked with the appearance of a value, a completed signal, or an error. The completed signal is there for the purpose of signaling that the event stream is terminated. Some event streams may never terminate. For instance, a stream of keyboard events will stay active until an unwanted exception terminates our code or the user closes his browser window. Let's see some event streams in action illustrated by the rxmarbles.com site. You can see the input stream at the top, the output stream at the bottom, and an operator between them. In this case, delay simply delays the input marble and emits an output marble after a given amount of time. As we move the marbles right and left, you can see that the delayed value moves accordingly. We can also change the values of the marbles with the map operation. As you can see, we multiply the value of the input marble by 10 and the output marble appears at the exact same time as the input marble. The bounce is also a very interesting operation. It emits marbles periodically, and the marble that is emitted is the very last marble that appears just before the sampling time. The bounce is very useful. For instance, if you have a stream of DOM events and the user may emit too many DOM events at the same time. For instance, imagine that you're driving a car with the arrow keys, and what happens is that you sample the direction inputted by the user, and you want to sample it once per, let's say, 40 milliseconds. You want to react to the very last user action that you read, and you throw away all the other user actions in those 40 milliseconds that preceded the last user action. So you can see that a stream can be used as an input for another stream, and operations transform either the value or the appearance time of the streams. Furthermore, these operations can also throw exceptions. Operations like map, reduce, filter, flat map, debounce, and delay can all be used and behave similarly to other functional programming libraries, with the exception that now we are transforming time-variant streams. It's also important that we are not mutating these streams, because we create new streams as an operator links an input stream to an output stream. Therefore, we regard these streams as immutable. Once we will start using these streams in practice, you will see the implementation advantages of using reactive programming. It is highly declarative, you can react to user events quite easily and quite naturally. You just describe what the problem is and you hide the implementation details. Functional reactive programming is designed around events and UI interactions, which means that you can naturally describe what happens after a user does something. We will use RxJS from the Rx family of languages. You might have seen RxJava, RxScala, RxSwift, or Rx.RB, or any other Rx languages. They work more or less in the same way. They may contain different operators, but the underlying concept is all the same. In fact, rxmarbles.com that you just saw as an example holds for most Rx languages. Let's now visit reactivex.io. You can see the languages here that you can choose from. We will choose RxJS, obviously. You can see the GitHub repository of RxJS. The activity is quite high. RxJS version 5 is available to you at the moment. So this was a theoretical introduction of reactive programming. In the next video, we're gonna put theory into practice. Just remember the main concepts, that we work on event streams. These streams are immutable, and operators can create a new event stream out of an existing event stream. We can observe and capture events of an event stream and process them accordingly. The advantage is that we're gonna get a highly declarative code that is very easy to maintain, very easy to extend.